Hello everyone, I am Someshwar Chanapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. In our previous classes, we have discussed if we apply point load or UDL or UVL in case of cantilever beam, so what will be the solution for shear force and bending moment and what will be the diagrams. So in this class, we will solve one numerical like in this numerical we have 4 point loads in case of cantilever beam. So here we named it as A, B, C, D, E and here we will calculate some shear force and find out shear force and bending moment. So let's start. First, calculation of shear force. We know that when we calculate shear forces, so there is nothing but the forces. So first we will calculate shear force at these points. First we need to choose one side, from that side we will calculate. So let's start from this point E. So shear force at point E will be yes, you can see at point E we are having only this 500 Newton. So there is nothing to add. Let's write it that 500 Newton. Next, shear force at point D. We need to remember that if we are starting this calculation from this side, so we will calculate like this, or if we are calculating from this fixed end, we need to calculate from this side. Okay. So now shear force at point D will be the summation of forces like 500 plus 800. So it will be 1300 Newton, right? So next, shear force at point C. So it will be like addition of 500 plus this D and here at C. So it will be this 1300 plus what? Your 300. So it will be 1600 Newton, right? Next, let's find out shear force at point B. So again, just addition of this. So it will be 1600 plus 400, that is 2000. Okay. So next is shear force at point A. It will be like addition of all these 4 forces. You can see at this point there is no load. So addition of these 4, that is the same with point B. So it will be 2000 Newton. Now we have the shear force values. So now how to draw? We know that in case of cantilever beam, we will have the diagram like linear. Okay. So in case of cantilever beam and if the load is point load, so we will have the shear force as linear. So let's draw it. You can see all these values is in what? Positive. Okay. So we will have the diagram, positive diagram. So here let's write it here. As we are having shear force at different values in case of different points, so here we can draw the different graphs for different points. So at point E we are having 500 Newton. Let's this 500 Newton will be here. Okay. Now what? Next is your 1300. Make it here. Right. Next is your 1600. Next 2000 Newton at point what? At point B. And you can see at point A and B we are having the same values. Right? Now our work is to draw the diagram like this. Okay. Let's join this. Here E to D we are having the force is 500 Newton. At point D it will increase, that is 1300 Newton, you can see. Okay. So now here this. As this diagram is like linear, so we are having the structure like this. Okay. Here this is your positive shear force diagram. You can write it here, positive. And if anyone asks like what will be your shear force diagram, you can show this part. A to E is your SFD or shear force diagram. Okay. We have clearly done this shear force diagram, and now our work is to find out what? Bending moment. Okay. First, calculation of bending moment. So how to calculate bending moment? Calculation of bending moment is nothing but here you have the load. So if we multiply the distance, we are having different distance here. Okay. If we just multiply distance with the load, then we will get bending moment values. So how to calculate? Let's see. So bending moment at what? At point E. Okay. So you can see as we are calculating bending moment from this side, here the distance is 0. Okay. Or you can say this is your end support. Okay. So bending moment at E will be what? Minus 500 into 0, that is 0. Right. Now what? Bending moment at D. Bending moment at D is going to be like this 500 multiply with 0.5 minus 500 multiply with 0.5. Also you can write like minus 800 into 0. So we will not take these values. It will be your what? Minus 250 Newton into the distance is in meter, so minus 250 Newton into meter. Okay. Let's calculate bending moment at point C. Okay. So bending moment at C, how to find out? This load with the distance here. So it will be minus 500 multiply with 1, again minus 800 multiply with what? 0.5. Okay. Now the answer is going to be minus 500 minus 400. It will be minus 900 Newton into meter. Okay. One question is there, like why we are taking these minus? These are in minus and we are taking the load value in case of shear force positive, but in case of bending moment we are taking it negative. Why? Because you can see the load is here in negative direction. Okay. In our previous classes we have already discussed the sign conversion, you can look at those videos to know what will be the sign convention and how to do those things, right? Next, bending moment at point B. So it will be, in case of shear force, we just do these additions, but here we need to mark everything. Like here, in case of B, we need to multiply 500 with this 0.5, this 0.5 and this 0.5. It will be 1.5. So minus 500 into 1.5, again minus 800 into 0.1, and again minus 300 into 0.5. So we will have the value as minus 1700 Newton into meter at point what? At point B. Okay. So next what? Bending moment at A. Again the similar process, like minus 500 multiply with 2, again minus 800 will be multiplied with 1.5, minus 300 multiply with 1, minus 400 multiply with 0.5. If we calculate it, we will have minus 2700 Newton into meter. Okay. As we are not having the calculator here, I have just taken these easy values. Okay. In our exam questions, there will be some difficult distances and difficult things to calculate, but the procedure is similar. So now let's draw the bending moment diagram at point A, B, C, D, E. As we are having the values in negative, so also we will get the diagram in negative direction. So you can see at point E, here we are having 0. 0, you can write 0 Newton into meter. Next at point D, we are having minus 250. So minus 250 Newton into meter. Again, what? At point C, minus 900 Newton into meter. Similarly, at point B, we are having minus 1700 Newton into meter. Here minus at point A, we are having minus 2700 Newton into meter. Right? Now our work is to just join these things. So here the diagram will be like this. Okay, it will be like this, and you can write it here negative. We are having the bending moment diagram in negative direction. You can easily remember that whenever we are having the load in downward direction, we will have the bending moment diagram negative, right? In case if we have the moment, then the diagram will change. Okay. So now in this numerical, we have the shear force diagram and bending moment diagram. So this is the easiest numerical on shear force and bending moment in case of cantilever beam. In our next classes, we will solve lots of numerical on basis of applying UDL, UVL and movement, lot. So to know those things, you need to stay tuned. Thank you so much.